Now that we have thoroughly inspected the index.cshtml page and used it as our springboard to learn the initial features of ASP.NET MVC, let's move on to another page that was scaffolded for us in the Views Products folder. I'm going to open up the create.cshtml page, and this will provide us a new fertile ground for learning some new things about ASP.NET MVC. But before we get there, let's pop open the productscontroller.cs in the controllers folder. And I'm going to scroll down to about line number 39 through about 60. And I want you to take note that there are two versions of a create method. There is one that has a method signature without any input parameters, and then there's another one that has a method signature that takes an instance of the product class. Notice that this input parameter is additionally adorned with an attribute. Now, we'll get to that in a minute. Now, besides the difference in the method signatures, can you see anything else that's significantly different between these two versions of the same method? Well, it's all wrapped up in this attribute that was applied to the second version. So that attribute HTTP post means that whenever a request comes in that is that basically is the submission of input controls on an HTML form and it's posted to the server, then this version of the create method will be called. If it's just a request, an initial request for the page that will display the input controls to the user, well, that's a get, and that will be displayed or handled rather by this version of the create method. Now, I just want to quickly review these verbs. Actually, there are 4 verbs defined in the HTTP specification. And until just a few years ago, we were really only familiar with 2 of them, the get and the post. So the get is a request for information from the server to be sent back to the client. And then a post means that on the client we have data in form fields, so like input controls on an HTML form. And we're going to send that information, we're going to post that information back. So that's why when you look at the source for a web page that has an HTML form on it, you'll see a form tag, and it will have a parameter called method, and it'll be set usually to method equals post, so the data will be posted to the client. It's simply just a different verb, and that data will be encoded in a series of name value pairs in the message body as it's posted or sent back to the server with that verb. Now, there are 2 additional HTTP verbs that have more recently been popularized since developers have adopted a RESTful URI architecture. And those 2 verbs are put and delete. But let me address the term RESTful, or REST, R-E-S-T. It stands for Representational State Transfer. It's a means of communicating intent from a client to a server. And it's become a popular way for any type of client to make a request to a server by utilizing the HTTP verbs along with a well-formed URI in order to indicate the intent. So it's a pretty big topic. I don't want to get too deep into it for now. We'll merely skim through it in this series of lessons. But let's talk about those 2 verbs, put and delete. Put is the equivalent to requesting an update of a given entity with the data to be updated, and that data is being sent again in the body of the HTTP request. And then there's also the delete, which is an instruction to delete the entity. So essentially what we have here between get, post, update, and delete are CRUD operations for any given entity within our application. That entity could be a row in a database, it could be an instance of a class, whatever. Now, honestly, put and delete aren't used very often. In web applications, they're more appropriate when used in a web API application, and we'll learn about web APIs, web services, things of that nature in another series. So we could apply any of those verbs as attributes on top of a given method. So even though it's the default, you can see here that there's HTTP delete, get, post, and put. There are a couple of others too, and we'll talk about those later. But these are the main ones. So if I wanted to add that, we can explicitly say that this is the get version, although that is implicitly, that is the default for action result methods. Let's take a look at this version of the create method. So clearly here in the get, we're asking for the web page that will contain the form. And then once we make changes to the form, or actually when we add new information like a new name and a new price for a given product, then those values will be posted back and it'll be handled by this method. Now, I already said something about this input parameter and that it's pretty interesting, but I'm going to start off by just saying that there's a lot to this, what's going on here. And so to start that explanation, I'm actually going to remove it and then work our way back to adding it to its full glory. But let me start off by just saying that we can essentially accomplish everything this method was accomplishing before by passing in an instance of product and then checking to see if the model is valid, but more importantly setting the product ID to a new GUID and then adding it to the products collection as a new entity and then saving those changes back into the database. We can accomplish the same thing by actually this little chunk of code right here, which goes about the same thing in a very different sort of way. So I'm just going to paste in this code, and you can see here, in this case, we're using an object called request, and this is actually an instance of an object called HTTP request, which is built into ASP.NET. You can get to it from web forms as well. And essentially, whenever a request comes in, whether it's a get or a post or whatever the case might be, all of that data in the message, and if you've ever popped one of these messages open, you'll see that there's a bunch of header information and there's body information. All that information is actually entered as properties for this request object. So we are getting at that object, and there's a collection of name value pairs that have been sent in. If it's a post, they'll be sent in as the name of an input control, so the name attribute of an input control in an HTML form, plus whatever was typed into that form field. If it's a get, then it would be the query string, so the name value pairs in a query string. But at any rate, we can access all those values through this collection, and we can just kind of use this element access syntax to get at a specific element that has the name and the name price. And we can retrieve whatever values were in those form fields. The problem with this approach is that it's weakly typed. Now, do you remember what weakly typed is a bad thing in .NET in general or programming? Well, essentially we're attempting to access values that are in this collection using a key, but we're expecting that key to match up with the names of input controls on an HTML form. And it's just that we're trying to access, using these magic strings, and hopefully we spelled everything inside the magic string correctly. If we didn't, we wouldn't even know about it until we actually were testing the application, and hopefully we caught it during testing. However, what we usually strive for is a strongly typed approach to anything in programming, especially here. So while this is a good approach, let me show you a better approach, or talk about a way in which the ASP.NET MVC infrastructure makes it easier to implement this in a strongly typed way. And so there's this feature of ASP.NET MVC called model binding. It's the topic of this lesson. And model binding simplifies controller actions by introducing an abstraction layer that automatically populates controller action parameters. It takes care of mundane property mapping, type conversion, anything like that that's typically involved in working with ASP.NET request data. So model binding seems kind of simple once we see it implemented, and we'll put a little example of that here in just a moment, but it's actually comprised of a number of parts that work together to create and populate objects that are required inside of your action result methods. So to get this to work this time, what I'm going to do is actually add back in two input parameters, and you can see that in each of these cases, the name and the price, we would expect these to be the name attributes of input controls, okay? And then below that, we can merely access whatever values have been bound to. So any values of the model that have been bound to name and price can then just be accessed like so. And then we could go ahead and then save these into the database, which is a step we didn't really talk about before that. Okay, so these two examples accomplish roughly the same thing, but in this case, the request comes in. At least the form fields come in as strongly typed input parameters to the create method that we can then access then later on in our application. We can count on them being of the right data type, and we're not working with magic strings. Now, ultimately, we're working with data that will be properties of a product class, and while model binding in ASP.NET MVC works great with primitives like we've used here, string and decimal and integer and things of that nature, it actually works pretty well with complex objects too. So we could actually change this, remove this, and just do this instead, product. And then we can kind of get rid of a lot of this stuff too and get back to where we were just a moment ago. And we'll just uncomment this out. Now in this case, model binding will take the form fields called name and price, and it will use them as properties for a new instance of the product class, and then it will pass that instance of the product class as an input parameter into our create method. So how is it that this actually works? How does model binding actually work under the hood? Well, it's a two-step process. First of all, there's the step of collecting values from the request as it comes in, and then secondly, the step of populating the model with the values. So when we use the term model here, we're talking about a view model, a class like product that is intended to be a view model, although here in this case it's also used as a persistence model. Let's not talk about that. So when the form is actually posted from the client to the server, as we've seen, the values are parsed into an HTTP request object. The next step is to extract those values using what are called value providers. And it's a feature of ASP.NET MVC that'll look in common places to grab out the data that it knows it needs in order to populate properties on a given model class. So it can look in several different places. It'll look in form fields, obviously. It'll look in route data. So any of the segments that come after the route, we talked about route dictionary values. It'll look in query string parameters if those are available. It'll look in other places too to find the data that can be used to populate the new instance of the model class that's being passed in. So these value providers know where to look for the data, but you can also create custom value providers if these aren't enough. I'm not sure why you'd even want to. I mean, these cover most of the usual scenarios, but the canonical example is that you could create a cookies value binder so that it will not only look in the form fields and the query string and the route segments, but it would also look in cookies and see if it can grab anything from there and use it as to populate the properties of a new instance of product in this case. I don't think that's something that, I really think it's an edge case. I don't think it's something that we would ever do. I'm not going to cover it in this series. If you really want to learn about it, go to Bing and search for custom value provider, and you should get close to articles on that. But once all the value providers have extracted the values from all these common sources, then they're mapped to individual input parameters like we saw here in this example. Okay, when we actually were passing in string name and decimal price, or mapped to properties of a model class like we saw here in this third example, or the first example really. So where does this mapping all get defined? Well, it's not overtly defined anywhere that a text box called name should be mapped to an input parameter or a property of a model class. This is another case where you rely on convention over configuration. As long as the input field, the query string name, the route data, whatever, has the same name as a property of the model class, then it's going to work. Okay. And by the way, this is another great reason why you should utilize those HTML, that HTML helper class, helper methods to generate form fields for you. If you were to rename a property of your model, no further change would be required, and the application would still just work. All this model binding would still just work. Okay. Okay, so now we've learned about model binding, the process of binding values from common input sources to the input parameter of a action result method. We've learned about value providers, the puzzle pieces that know how to inspect a given input source and extract the values to be bound. And the final part that I want to discuss is the attribute that was applied to this input parameter. You'll recall that we had this attribute, I'll paste it back in now, here, that adorned this input parameter of type product, this bind attribute, all right? And so take a look at this web page here. Let me find it real quick. Where did I put that? Oh well, I think I lost it somewhere. Let me just type it in. If you go to bit.do/overpost, I created a little shortcut to it. But that'll take you to this page on the ASP.NET website under their documentation there. Implementing basic CRUD functionality with the Entity Framework and ASP.NET MVC application. If you go down to the part where I actually linked to, it actually talks about this. It talks about something called the validate anti-forgery token attribute and the bind attribute, which is what we're actually using here. And I'm going to devote another lesson to cross-site request forgery and how to combine it with the validate anti-forgery token attribute a little bit later, so we'll cover all the stuff that's talked about in here. So I'm going to close this down. I just want to focus now for the time being on the bind attribute. So if you read that call out from that article, it outlines a scenario where you don't want all the fields of the model to be initialized based on the values from the post. And the example that they give is a fictitious secret field that you might have on this product class. So we have not only the product ID, the product name, the price, but we also have some secret field, some property that we don't want exposed to the user. We want it hidden. Now, in this scenario, this would be populated by some other feature of your application, let's say, or by somebody in the organization with sufficient permissions to do so. But by all means, it's not to be accessed inside of the context of this application or by any of the application's users. But by default, model binding will attempt to bind everything in your model if it's possible. So this term overbinding, so we typed in bit.do/overbind. Overbinding is a term that describes how a hacker could guess at additional properties of your model that you do not want your model bound to. Then that hacker could insert fake form post values for that property. In other words, somebody could guess at the secret property secret and use a tool like Fiddler to send a fake value like secret equals 123. Model binding in ASP.NET MVC would then attempt to map it to that secret property of the model of the product class, because that's what it knows how to do. So in this scenario, it's considered a best practice to explicitly limit which fields can be bound when using data binding or model binding. That's the purpose of this bind and then this include equals. Here we're saying only model bind to the product ID, the name, and the price. Exactly these properties, nothing else. Finally, as that article points out, and I've already shut it down unfortunately, one good way to protect against this scenario completely is to not force your entity data model to serve two purposes. What did I say in the previous lesson? So if you were to transfer data from the presentation layer to the domain layer using data transfer objects in a proper fully layered application, then you could easily avoid the perils that are associated with overbinding. You have control of what gets passed and what gets set, and you can pretty much take control of everything in that process. But with model binding, you accept all comers, so to speak. So let's recap what we talked about in this lesson. We talked about model binding, which maps the values created from form fields into values that are input into action result methods in your controller. Model binding relies on value providers which know how to look in common places in a typical HTTP message body for values that share the same name as properties in your model classes. Model binding dramatically reduces the amount of code required to accept and work with values from an HTML form. And then we also talked about the bind attribute and how it protects model binding from overbinding. When somebody attempts to maliciously write or overwrite model data in create and edit scenarios like we'll be looking at here. Okay? Model binding is a big deal in ASP.NET MVC. There's a lot of working pieces to it, and now we have it in our toolbox, and we'll continue to use it throughout. All right, we'll pick it up in the next lesson. We'll see you there. Thanks.